Hello and welcome back. Today we're gonna finish the project of the 10M-6 PLL board. It's a PLL board with 6 outputs that you can program between I think 200K and 200 megahertz. I have another video about it. In that video, I also have the links to the software to download because that was a bit difficult to find. So I will put that here in the bottom. And yeah, it's still I put it in a box, but it needs to be in a proper casing, and that we are gonna do today. And also a little spoiler. I have here a huge power supply. It's from Delta Electronica. This is switch mode. We also have the linear ones here. Yeah, in the Netherlands, they are very famous because probably, especially if you were around my age, you had this in school because they are almost unbreakable. They're about 40 years old, so I will do that in one of my next videos, but I just want to show you what is coming. The Keathley 199 is still coming. I have here a 175 with the backlighting option. As you can see, it's almost the same as the 177 with a little change, and we still have the Sigland signal generation, the SDG 1010. So we're gonna play with that later, and we're gonna finish the board. Okay, well, this is more or less where we ended last, and I thought it needs to be in a proper box. I still had one of these aluminum boxes. I think it's from Farnell, and it almost fitted. Yeah, almost is not exact. So then I just cut out the corners, and then well, it could more or less fit. And then I just put one of these cables. As you can see, that is the SMA, and then I just put these through the box, and then it's all nicely closed. Then of course I need little cables for the power. And for the LED, yeah, I ordered these in China, so instead of one, you get 10. So we have those, and for the serial cable, we have these with 5, so we can just pin them on. And then I needed a DC connector, of course, so I have also a few of those. We will drill those in. Yeah, because the PCB you cannot really get stuck in this box. So I also have these bolts and nuts. It's nice. And of course for the serial cable, that I just thought let's get the box of these. I think it's 5 of each, of the female and the male, and I will just put one of them in the box also. And then later I was looking and I thought, oh, this box looks completely different from the other boxes I have from the distribution amplifier. So I looked a little bit better, and I found at least it is 10, 5, 10. So 5 by 10 centimeters, 10 in the back, like all the other BG7TBL boxes, and with a nice front. And the box itself is slightly different, but the size is exactly the same, and I like it. And it's not green, but yeah, we want metal. It's a little bit more difficult to drill, but it's much nicer for the grounding. And so I'm gonna build it in this box in the end. And also it's very convenient, whoops, because you can just slide it open. It's a tight fit. And then we need to see if the PCB goes in like this, or maybe, hopefully, it is a perfect fit like this, which it also is not. Well, at least it fits like this, and it is a super perfect fit. And yeah, then we need the plastic stands to not make a circuit on the bottom, and then we probably have a nice looking. Yeah, and before I make the design of the back and the front of the housing, I need to think, because these cables are not that long, and I bought them, and of course it takes 3 weeks before you get them, and now I find that they are actually a little bit short. So I need to be smart. So I need to see, this is an output and this is an input. So this will just about make it, and this one too. So these will probably be on this side, and I have here an sorry, this is out and in. So these will be on this side, and here I have an out 6, and I think it can just make it here. So then this will come here, 5 there, 4, 3, 2, 1, and then the 1 can probably just make it up to here. So that's going to be on this side. But first I need to see if it also can go up. So first let's make sure it doesn't short circuit on the bottom. So we're just going to put these little spacers in the bottom. Okay, this is good. It does not short circuit, and we have a little bit space. So that is good. You can see underneath it. So I'm positive this will work. I'm not sure I was clear how to fit this cable, so I will zoom in more on the work. Okay, well, there are a few things we need to take into account. This cannot be fitted like this, so it needs to be like this. And of course, I want to put all the outputs on the same side and the inputs on the other side. And I want my power switch in the front. So we have here out 1 up to 6. And here we have the output, just a 10 megahertz out like that. But this is gonna be, we are not gonna make it. This is too far away. If we screw this, nah, it's not it. So that means that's gonna be here. No, that will be on this side. And the same for this one. It will be on this side. Just see if it even wants to bend it much, but I think it will. It needs to, because that's, oh, it must, yeah, that will work. So that will need to go to here. That's one consideration. The other is, and that's more on the other side. And this is a tight fit. The less force you use, probably the better it works, these things. But okay, so, but that means that if we're gonna go our connectors to the front, we will need to cross them, because these cables are kind of rough. So that means this one is gonna go here, and this is a good fit. As you can see, this is possible. Then this goes, this one probably goes low, and this one goes high. And then this one goes low, and this one goes high, this one goes here, and this one goes here. So, but it does mean it cannot be too far to this side. So that means my power switch, no, it's in the other side. This is purely the back. No, but I want my exits on the front, because my reference and my reference out can be in the back. So my power switch is going to be here in the front. And these cables need to be here, but I cannot be too far that way. But that's okay, because if I just make 2 rows of 4 holes, that will be fine. Switch, LED, and then my outputs output 1, 2, 3, 4, 5, 6. And then, so that works. But also, if I make a nice division here, it cannot be too low because then I hit my connectors. So it really means I need to be on almost on half and higher. That will look a bit weird, but yeah, there is no other way you can do that because then it needs to be, it's 4, yeah, maybe it will be exactly in between the pins, but yeah, that's not it. So probably it needs to go in half, but I will draw first a line. This is exactly the reason why I use the lowest available, because I have different sizes. For instance, I also have this one. But when I do that, then the circuit board is going to be so high that I probably cannot even put 1 row of pins. So, and also I probably need to fold them backwards. But let's see if we put half. Okay, if we do it equally, then we have 2 centimeters, 4 centimeters, 6 and 8 and 10, and then we have an equal division for 1 row. And let's see how that works out if we put that here. I think actually very well, because we can move a little bit the PCB, and let's see how it even needs to be like this. So if we move a little bit the PCB, then you can see here it will be exactly in between the two connectors here, in between here, so that we have enough space to move it around. The LEDs are no problem, and here the power switches come, so that's also not a problem. So now we need to find a nice row, and instead of dividing it exactly, maybe we can just do a centimeter below, and then we have a little bit more space in between. Okay, I switch off the light, then it's better visible. So instead of putting it exactly in the middle, I will just do 1 centimeter below. So then we have at least 1.5 in between. This cannot go much lower because we come into problems. Here we need to have space for the bolt and nut, but also for the casing. So, but let me just think it will work. So we put here 1 centimeter, and here 2.5 and 1. Yeah, and also it's a little bit higher. 2.5 and 1 is actually right there. That seems about right, but then we doing for now. Yeah, it's 1/2 mil. This one needs to go up a little bit, but that's okay. Let's put the and so that's where they're going to be. But we also need to think if we have enough space for the casing. So, okay, so this is how much space we will have from the top. And that is also not a problem with that. And that's So I think that we then have a solution. It's not getting to the PCB and it's not hitting the. So, okay, this is what we need. So we need here big holes for these. 1, 2, 3, 4, 6 of those. Here we need for the switch, and we have 2 LEDs, so I'm not putting the center, but just outside the center, I put the 2 little LEDs. And yeah, I will not drill on my desk. I will drill it and then I come back. Well, that took a little bit of time, but I think this is all nicely. You can see the big holes for the SMAs, the LEDs, and the switch. Well, this will go nicely. The LEDs don't even need to be glued because they have a super tight fit. So I think that will look really nice. So now I want to connect it just to see how much space we have for the other side. Well, it is a little bit of a tight fit, but as you can see, I put one by one, and now they are also numbered like 1, 2, 3, 4, 5, 6, so that's okay. We can just tie the nuts, and as you can see, this will fit because you can still push a little bit. But yeah, maybe a bigger box would be nicer, but it does fit. And here we can put the 2 LEDs in the switch. So, and we can still use the connectors in the back, as you can see. It's gonna be all very tight fit, but it does fit. So that was a lot of work, a lot of mechanical, and this is the result. We have here a very nice box. I put the inputs on the top because the stickers were ugly in the front. And here is the back. So the serial, the reference in, reference out, the DC plug, and we have here the power switch. We have here the power LED that will be blinking when it's powered on, and it will be steady on when there is a lock on the external input, and this is also a lock, I think. So let's just connect it. I have here also the radio frequency counter. I have here my 12 volts. This thing runs on 5 volt and it has a 3 volt regulator. So I put an extra 5 volt regulator in here and I'm cooling it on the housing. So screw fitted exactly in there. So I just put my 12 volts. And if I switch it on, it starts up. And now it's blinking because there is no external reference. So we're gonna take care of that. I have here a BNC with SMA. So I'm just putting it on my reference here. We put this on the input. You need to do this exactly straight. Okay, well, here we have it. we have external input analog, so that is good. And I already programmed the last time. You can see that in the other video. So let's see, the input number 1 should be 10 megahertz. Well, you see it's 10. The second I put on 10, that is 10. The third should be on 1. Well, as you can see, it's 1 megahertz. Then this is 50 megahertz. And then I put on 25, 75, no, 25, here it is 25. And we can do a little bit longer. And we can add an extra digit. A little bit longer. Perfect. And well, I'm pretty sure that that it will work with the serial port, but then my video gets way too long because I'm also need the serial switch because I only have one port, and on my other port is the GPSDO. So, but as you can see, that works. And does the reference output also work? I would think so. Ten megahertz out. I would say that's 10 megahertz out, so that works. So that's it. We built a night casing around our 10M-6 PLL device. And yeah, it's a lot more usable. It's the same size as the other BG7TBL devices, also with the reference in the back, in and out. So I think it's a perfect fit. So yeah, you can find everything in my links below, of course. Thank you for watching, and I hope to see you next time.